Welcome to The Explainer. I am absolutely thrilled you're here today because we're doing something a little bit different. Picture this. We are putting on our detective hats and stepping straight into the ultimate exam room crime scene. Welcome to CSI Cambridge Exam Room. I'm your lead detective, and today we are opening a brand new case file. We're calling it the case of the failing high tariff question. We are going to forensically crack the code on literally one of the most misunderstood, heavily penalized areas of the entire Cambridge AS and A-level mathematics syllabus. I'm talking about section 4.2, Kinematics of Motion in a Straight Line. To help us out, I've brought along two rookie forensics agents. First, we have Agent Alex. Alex is totally obsessed with isolated facts and loose footprints. And then we have Agent Sam, who loves throwing out incredibly vague theories. Together, we're going to show you exactly how to protect your marks from vanishing when calculating distance, speed, displacement, velocity, or acceleration. So, let's open the file and dive in.
Right off the bat, let's look at the central mystery of our crime scene. Why do students find evaluating evidence and drawing conclusions in kinematics so incredibly hard? I mean, think about it. It's just objects moving in a straight line, right? Well, not quite. The real complexity, the place where the marks are being stolen, lies in the subtle differences between our core variables, distance versus displacement, speed versus velocity. Nailing this requires a level of forensic precision that goes way beyond just plugging numbers into a formula. You see, students struggle because kinematics isn't just about finding a quick answer. It's about constructing a flawless, logical argument using mathematical evidence.
Okay, here's our forensic roadmap for today's explainer. We'll hit 1. Core theoretical principles. Then 2. The procedural framework. Move on to 3. Problem-solving strategies. And wrap up with 4. Top examiner warnings.
Let's start with Section 1, Core Theoretical Principles.
All right, let's look at the crime scene. Agent Alex is over in the corner, dusting from memorized equations, thinking that's the key. Agent Sam is just guessing at vague concepts. Neither approach works. The theoretical architecture of kinematics rests on precise definitions and, crucially, causal relationships. The Cambridge Assessment Framework targets 3 distinct cognitive domains: knowledge and understanding, application, and analysis. The examiners have stated very clearly that their academic benchmarks require logical, structured reasoning. They prioritize analytical depth over superficial breadth. What does that mean for you? It means they'd rather see you deeply analyze the relationship between a velocity-time graph and acceleration rather than just vaguely vomiting up 20 different formulas.
Let's run a UV highlighter over the actual principal examiner reports, because this reveals the secret weapon of top-tier students. Look at this direct quote. Candidates referencing cross-topic connections achieve significantly higher marks. Bam! There's your hidden evidence. Integrating your kinematics work with other syllabus areas, like calculus for example, recognizing that velocity is actually the derivative of displacement, is exactly how you unlock those high tariff points. The examiners want to see that you understand the entire structural framework, not just one isolated topic.
Moving on to Section 2, the procedural framework.
Okay, before we crack the procedural code and look at the actual methodology of taking the exam, I need to pause the case file for just a second. To ensure you never miss our weekly forensic investigation breakthroughs and always outsmart the examiners, you need to subscribe to Ace the Exams at the handle @AceTheExams right now and turn on all notifications. Okay, back to the case. Let's look at the ultimate forensic tool, the method mark strategy. This is the assessment principle where marks are awarded for your step-by-step analytical process, not just the final answer. Examiners are desperately looking for your methodology. If you just scribble down a final answer and it's wrong, boom, 0 marks. But if you slow down, lay out your clear notation, and show your logical sequence, you secure method marks even if you make a tiny arithmetic mistake at the end. Your process is your ultimate insurance policy.
To guarantee you secure those method marks, I'm going to act as your detective and give you our standardized 5-step procedural framework. Think of this as your mathematical peel template for kinematics. Step 1. Deconstruct the question forensically. Look for the command words. Step 2. Extract your relevant data from the texts and tables. Step 3. Select the right analytical framework. Now, Step 4 is where you really have to focus. Execute with clear notation. Seriously, do not mix up your V and your U, or you'll contaminate the whole scene. Finally, Step 5. Present the final result with the exact correct terminology and units. If you follow this trail of evidence every single time, you become bulletproof.
Let's move into Section 3, Problem-Solving Strategies.
It is time for a live forensic workshop. We are transitioning into the specific strategies required to master higher-order assessment objectives. Challenge number 1.
Imagine an authentic exam question in front of you with a 60-second visual timer ticking down. Go. You need to use our ultimate deconstruct, solve, evaluate mechanism. You identify the given info, break it into logical steps, and solve systematically. But look closely at step 4. Check for reasonability. If you calculate the velocity of a bicycle and your answer is literally faster than the speed of light, something went horribly wrong in your processing. You have to extract the data, verify the results logically, and then culminate your work in evidence-based conclusions, making justified recommendations. You are building a rock-solid case.
Let's run challenge number 2. We're looking at a flawed student snippet. Agent Sam would probably write a descriptive level answer, just identifying basic similarities and stating facts, but that kills the grade. The evaluative level, the right side, is what the examiners demand. This means pinpointing similarities and differences using comparative connectives, supporting every single claim with mathematical evidence, and drawing actual conclusions. Don't just say an object stopped, prove mathematically exactly why its velocity is 0 at time t, and evaluate what that means for its overall displacement.
Finally, Section 4, Top Examiner Warnings.
Okay, listen up. We are starting the final autopsy. I need you to pay incredibly close attention, because we are looking at the direct transmissions from the principal examiner reports. These are the pitfalls that steal marks from perfectly capable students. And, according to the forensic data, there are exactly 3 fatal mistakes students repeatedly make in the kinematics section. Just 3 massive roadblocks between you and your target grade.
Let's break these 3 mistakes down. First, answers are far too vague. Remember Agent Sam? Examiners hate vague theories. They want specific details. Second, forgetting format and presentation conventions. If you drop your units, or your handwriting is so sloppy that your acceleration looks like a displacement, you are practically handing your marks back to the examiner. And third, the absolute biggest crime. Answers are not specific to the context given in the problem.
Let's zoom in on that third point, because it's a massive examiner alert. Generic answers versus context-specific answers. Agent Alex loves to just regurgitate a memorized formula without adapting it to the context. That's a descriptive trap. Let's look at a newly engineered full-mark approach. To succeed, you must link every single mathematical point back to the exact given scenario. If the problem is about a train braking, your concluding statement shouldn't just generically say x equals 5. It should specifically state, the braking displacement of the train is 5 meters. Context is absolutely everything.
As we wrap up this autopsy, I want to add one more tool to your forensics exam protection checklist. Specialists recommend a highly effective memory hack. Use a visual story method to encode these concepts. Don't just stare blankly at the letters S, U, V, A, and T on a page. Build a quick visual narrative in your mind about an object moving through physical space. This encodes and locks in those causal relationships between displacement, velocity, and acceleration, making it so much faster to retrieve the right framework under exam pressure.
So let me leave you with this final provocative thought. Now that you've got the complete examiner's playbook, will you actually utilize the method mark strategy and strictly link your answers to the context in your very next past paper practice? Because knowing this stuff is only half the battle. Applying it is how you win. Treat your next practice session like a forensic investigation and protect your marks. Now here is your final directive. I need you to subscribe to Ace the Exams at @AceTheExams, enable all notifications, and right now, drop a comment with your current level and your target grade. Thank you so much for joining me in this explainer. Class dismissed, detectives.